All right, let's jump right into today's explainer. We're looking at what is arguably the ultimate hostile dining room. Think about the incredible biological and engineering gymnastics it takes to just keep a human being fed in the absolute extremes of space. We're talking a wild intersection of human physiology, food science, and aerospace medicine. Now, to kick things off, I want you to think about this slightly bizarre question. Why are highly trained astronauts, people operating multi-billion-dollar equipment in orbit, absolutely obsessed with hot sauce and tortillas? I know, it sounds super quirky, but stick with me. By the end of this explainer, those weird space cravings are going to make total scientific sense.
Here's our menu for today. We'll start with the environment, look at the engineering constraints, check out the tech innovations, dive into the mind, and finally wrap up with the future of extraterrestrial eating.
Let's hit part 1, the environment, the hostile space dining room.
Look, before we can even talk about the menu, we've got to talk about the dining room itself. Eating down here on Earth, it's pretty effortless. Gravity does a lot of the work pulling our food down, and our bodies are basically just doing what they're designed to do. But space? Space is physiological chaos. Microgravity completely messes with gastric emptying and digestion, and since your bones and muscles aren't getting that constant mechanical workout from gravity, you start seeing rapid bone demineralization and muscle atrophy. Throw in some cosmic radiation, and honestly, it's just an incredibly stressful place to try and digest a meal. And because of all that extreme stress on the body, we get to this number, 3,200. That's the surprisingly high maximum number of kilocalories an astronaut might need every single day just to maintain their baseline energy, which, introduces a massive logistical nightmare. How on earth do you get that much energy into a person whose body is literally fighting its environment?
Well, the answer is that space nutrition is practically medicinal. To fight off that rapid bone demineralization we just talked about, astronauts need this highly targeted cocktail of protein, calcium, and vitamin D just to keep their bones from fracturing. And that cosmic radiation? To fight the cellular damage it causes, their diets have to be absolutely packed with specific antioxidants. We're talking vitamin C and E, selenium, and polyphenols. Up there, every single bite has to pull double duty and actually protect you.
Moving into part 2, the engineering. Designing the perfect space meal.
Okay, so we know what nutrients they need, but how do you physically pack 3,200 calories of complex nutrition into a tiny, weightless metal can? Space food has to meet some insanely strict payload requirements. Storage space and weight are at an absolute premium. Every single gram costs a fortune to launch. So the food has to be hyper-nutrient dense and lightweight. It's got to be shelf-stable for long missions, often exceeding a year. It needs to be easy to prep, and, maybe most famously, it has to be absolutely crumb-free.
Which brings us right to one of the all-time great space debates, bread versus tortillas. Down here on Earth, a breadcrumb is nothing. But in microgravity, a crumb is a rogue floating projectile. It can be inhaled, or worse, float into and totally destroy a piece of ultra-sensitive equipment. That's exactly why tortillas are the absolute superstar carbohydrate for space agencies. They provide tons of energy, they're super easy to pack, and critically, zero dangerous crumbs.
Up next, part 3, the tech. Innovations in food technology. Food scientists and engineers have spent literally decades trying to meet those crazy payload constraints without just feeding astronauts some joyless, unidentifiable mush. And the evolution to meet these constraints is pretty incredible. Back in the 1960s, astronauts were stuck squeezing these gross little pastes out of tubes. Nowadays, we lean heavily on freeze-drying, which locks in the flavor and nutrients, but strips out all that heavy water weight so it can just be rehydrated later. And looking to the future, we're heading straight for real-deal hydroponics and 3D food printing. Right alongside freeze-drying, we also have thermostabilized foods. This is basically a heat treatment, honestly a lot like commercial canning. But it's the brilliant secret sauce for keeping heavy, comforting meals like a rich stew or a hearty meat dish perfectly safe for over a year without any fridge at all. By sealing them up in modern vacuum pouches, these heavy-duty meals become safe, convenient, and super easy to handle in zero-G.
All right, part 4, the mind, psychology, and sensory adaptations.
Keeping an astronaut's body alive is a big enough challenge. But keeping them sane and actually wanting to eat, that's a whole other beast. Astronauts consistently report that foods just seem way less flavorful in space, and that severely reduces their appetite and overall food intake. Menu fatigue is a massive red flag here, because if the food tastes like cardboard, astronauts simply stop eating enough, which means they aren't getting those crucial nutrients exactly when their bodies need them the most.
So why does everything taste so bland up there?
Well, it's this fascinating biological domino effect. Step 1. In microgravity, your bodily fluids aren't being pulled down to your legs anymore, right? So they all shift upward toward the head. Step 2. That shift causes facial puffiness and some pretty severe nasal congestion. Step 3. Because they're permanently stuffed up, their ability to smell heavily drops off. And Step 4. Since flavor perception relies so much on smell, everything suddenly tastes incredibly bland. It's basically like trying to enjoy your favorite gourmet meal while having a permanent, mild head cold. That's the daily reality of eating in orbit.
And hey, that perfectly solves our hot sauce mystery from earlier. Because of that severe fluid shift and the loss of smell, astronauts actively crave the most aggressively spicy, heavily seasoned foods they can get their hands on. Chili sauce, raw garlic, hot peppers, sharp mustard. They use these intense condiments just to blast right through that space-induced congestion so they can finally taste something. It's a pretty wild biological adaptation if you ask me.
But the psychology of eating is about way more than just flavor. When you're in a tiny, confined space, millions of miles from everything you know, meals become these vital psychological anchors. They offer a rare slice of comfort and normality. Space agencies actually go out of their way to provide a massive cultural variety of foods to fight off menu fatigue. Plus, getting the whole crew together for shared meals boosts cohesion and morale. It really cuts through the isolation. They even fly up special meals for holidays and mission milestones. It's not just fuel, it's a direct connection back to Earth.
Finally, Part 5, the future, extraterrestrial eating.
As humanity gears up for these massive, long-duration missions to lunar bases or Mars, relying on standard resupply drops from Earth is just going to be impossible. The game changer here is bioregenerative food systems. We're talking advanced hydroponic and aeroponic cultivation, allowing crops to grow totally soil-free using barely any water. And guys, this isn't sci-fi anymore. Right now on the International Space Station, experiments have already managed to grow and harvest fresh produce like lettuce and radishes straight up in the void of space. How cool is that?
Then, factor in the incredible potential of 3D food printing. Imagine a Mars mission where a 3D printer takes long-lasting base ingredients and synthesizes them into highly customized meals. The crew could have precise, daily control over their exact nutrient needs, the texture of the dish, and the flavor profile, all while maxing out shelf life and generating almost zero waste.
And that brings us to one last really profound thought for you to chew on. As we engineer these hyper-sustainable, low-water, maximum efficiency meals to survive the extreme isolation of Mars, what are these space-age innovations eventually going to teach us about solving agricultural challenges right here on Earth? Because as it turns out, figuring out how to survive out there in the stars might just be the exact key we need to thrive right back down here. Thank you so much for joining me for this explainer. And as always, keep staying curious.